the objective of the organization is to make profit. So in this process of maximizing profit, not all resources are all the time abundantly available, but we see that sometimes some of the resources are not abundantly available. There is some kind of a constraint or um, a limitation on to what extent they are available. For example, material may not be available. Maybe that region in which the unit is set up is there is some kind of a limitation in acquiring material, or labor is not available, or the capacity to use the machines is also limited. Things like that. We see that there are certain the resources which are not abundantly available all the time. If they are not available abundantly, in that case, they cannot maximize their profit. Whatever is their expected profit, that is not possible to achieve. So, if that is the situation, if they cannot achieve the profit according to what is their expectation, what best way in which they can achieve the objective? That is what has to be looked into. In case there is only one resource which is limited, that is short in supply, uh, the technique which is used is called as key factor analysis. If there are two or more resources, then the technique which is used is called as linear programming. So there are two techniques. One is key factor analysis and the other one is linear programming. We are going to look into these two things in today's class. So what are the steps in key factor analysis? Now remember, there is only one resource which is short in supply or constraint or limiting factor. So if that is the case, how do they maximize on their profit? So given that constraint, with that constraint being present, how do they maximize their profit? So there are steps which are mentioned: calculate contribution per unit, calculate contribution per unit of the limiting factor, then rank them in the order, allocate resources. I'll explain that to you. For example, let's try to understand with another example about how to work it out. See, let's say the student is writing an exam and realizes that there is only half an hour time remaining. In this half an hour time, let's say there are two sections which the student has to attend. One is attempting an essay answer, and another section is answering the MCQs. Let's say if this is an example, if we are looking into, if we are taking this example, so what would the student look at? Is it possible that the essay can be finished in 1 hour's time? Is what is the first thing which will be considered? Will he be able to do that? Second, the is it possible to finish MCQ? So um, if if out of this resource, which is availability of time, can he finish both of them? It seems that both of them cannot be completed in that short time. Then which one gives more marks? Which section would, if he attempts, which section can give him more marks is what the student will think about. So we see that um, in a less time, MCQs can be finished, and MCQs, the chances of scoring full marks on that is little relatively higher than answering an essay and scoring full marks. So the student would first think about maximizing the marks. So the time will be first allocated to MCQs. Then after that, if some more time is remaining, then he would attempt going for the essay answer. So that is management of resources. We see that the I think you also can relate to that. Such things happen in the examination. So here also there is some resource which is limited, which is constrained, which is not abundantly available. If such a situation arises, if there is some resource which is not abundantly available, if that is the case, how do the businesses take decisions about maximizing their profit? First step is that contribution per unit is calculated. Why not profit per unit? Yesterday, the previous class we have discussed about profit is not taken into consideration, but rather only the contribution is taken because fixed cost is fixed in nature. It doesn't change with the changes in the decision. So the controllable profit here in this case we see that it is contribution. Therefore, first calculate what is contribution per unit. After that, find out what is the profit available, that is controllable profit available for every single unit of the limiting factor. Like in the example, for every single minute of that limited time, how many marks can be scored? So that's the criteria for which the decision was towards the answering MCQs. So like that, if in case of business, for every single unit of the limiting factor, how much profit is available is the next step which has to be calculated. Then based on that, the ranking of the products will be taken up. Based on the ranking, the resources also will be allocated. So those are the steps in key factor analysis. So quickly let's look into one second. I'll just put you through the exam kit. Emperor. Just a second. This seems to be stuck. The question on the screen, limiting factor, question number 99, it says that a company has the following production planned for the next 4 weeks. The figures reflect the full capacity of the capacity level of operations. Planned output is equal. Okay. Planned output is equal to the maximum demand per product. There are four products A, B, C, D. Then certain other details like what is planned output, direct labor hours per unit. Direct labor force is threatening to go on a strike for 2 weeks out of the coming four. This means that only 2,160 hours will be available for production rather than the usual 4,320 hours. If strike goes ahead, which product or product should be produced if profits are to be maximized? Please place a tick in the boxes in the table below as appropriate. Let's take this question and then okay. Question number 99. Let's solve this one. The question has four different products A, B, C, D. There is one resource which is limited. That resource is availability of labor because the direct labor force is threatening to go on a strike. So only we see that only limited number of hours are available. This means that only 2,160 hours will be available for production. Otherwise, 4,320 hours were otherwise available. Now there is a limitation on how many hours are available. So then they have to plan accordingly. Allocate. See what was requiring 4,320 hours. Then the production was taken up. Now the production will have to be adjusted because almost half of the time only is available. So how do they decide? Straight away, do they go on reducing the number of units proportionately, or what is the decision criteria? So the concept would be about whichever product is more profitable. That product will be given focus, will be given importance as to how many hours would be allotted to that. So the criteria will be to allot the resources. Let's see, there are four products. We see product A, then product B, then we see product C, then we see product D. Step number one is first we need to find out what is contribution per unit. Selling price is given, raw material, direct labor, variable overhead. So the first three items are variable in nature. Material and labor are variable in nature. Then we have another variable overhead cost. So three items added together that will give us the total variable cost. From selling price, if the variable cost is deducted, we would get what is the contribution margin. Contribution margin is the controllable profit. So that decides about which one is more profitable. In any case, whether they produce more or less or anything, fixed cost would remain same. So that is not considered for decision criteria. So it is the contribution margin which is important. So let's start with that. So write what is selling price per unit. For each of these things, we see 160, then 214, then we have it as 100, then we have it as 140. After selling price, then we have to deduct the variable cost. Three items are there. The raw material cost, then we have direct labor cost, then we have variable overhead cost. Okay, let's write what these three items are. Now find out what is contribution per unit. That is step number one. So please make a note of it until here. Which one is the constraint? The constraint here, which one of it is a constraint? Talks about the direct labor hours is the constraint. Earlier it was they were using 4,320 hours. Now the availability has come down to 2,160 hours. So the decision will revolve around the constraint. Whatever is the limiting factor, every decision which is taken now will be considering the limiting factor. It is not that all the resources are freely available, abundantly available, as much as they want they can use, is not the scenario which is available now. So considering that, their focus will now shift towards what is the um, limiting resources, so limited factor. Um, if if labor is the limiting resource, how many hours of labor hours is required by each unit of product A, B, C, D. So we see that direct labor hours per unit. So we have test 6, then 8, then 3, then 2. So we have contribution per unit of labor hour. So per labor hour. So for every single labor hour, how much contribution is available, which will be the total contribution of 46 is available for 6 hours. For 1 hour, how much is that? So 46 divided by 6 gives us what is the contribution available for every hour of direct labor hour used. For every direct labor hour used, how much contribution is available? So that is what has to be calculated. Now, from this we have to rank the products. So ranking whichever has the um, highest contribution per labor hour will be ranked first, because that's the constraint. Second in the order goes A. A is the second one. Then we see C is 3, and then we have D as 4. Now based on the ranking, we see D is most profitable. Every 1 hour of the every 1 hour used by product B, it gives a contribution of $30. Okay, so as much as is required by D, first allocation will be made to D. How many hours are available? Total number of hours available are 2,160. I hope you are able to follow. Any problem, please stop me. If there is any issue or about not being able to understand, please stop me. Total hours available, we have this as 2,160 hours. then out of 2160 hours, as many hours which are required by D should be allotted to D first. So less hours allotted to D. How many hours are allotted to D? The total number of planned output for D is 400. Each unit requires 2 hours. So 400 into 2. 800 hours are allotted. So how much will be remaining? 1360 hours are available, remaining hours. Then out of 1360, then the one which is second in order, A. So whatever is required by A it should be allotted. Less hours allotted to A. So how many, what is the planned output for A? A has a plan of 300 units into 6. 300 into 6. But do we see that 3 6 are 18? 1800 hours, are they available? No, they are not available. Only 1360. So the requirement is 1800 hours are required to take up the production of all the units of product A. But that many number of hours are not available. Therefore, out of this so out of this 1360, as many number of units they can manufacture, they would take up manufacturing that many number of. So number of units of A produced is equal to 1360 divided by each unit requires 6. So how many units would be produced? So that is 227 units will be produced. The question is asking, if the strike goes ahead, which or product should be produced if profits are to be maximized? Place a tick in the boxes in the table below as appropriate. So which two products would be produced? Even if it is partial also, A will be produced and D will be produced. So A, we see that produced will be A and D. Not produced will be B and C. I hope you understood the concept. Is this clear? Is this clear? Okay. So now we left in between one topic about throughput analysis. So let's go to that throughput analysis once, and then when we started with throughput analysis, it says it is an application of key factor analysis to production bottlenecks. So when there are bottlenecks, when there are constraints, when certain resources do not allow them to take up the production as expected, then in that case, we are applying key factor analysis to decide which ones to be produced, which ones not to be, which products are not to be produced, can be decided. So that is the usefulness of this particular technique. So on par or similar to that one, we have this concept called as throughput analysis. Throughput analysis talks about application of key factor analysis to production bottlenecks. The way we have done key factor analysis is the same here also, but the only difference is under throughput only the material cost is considered to be as a variable cost. What about labor and variable overheads? That those are also variable costs. Basically, now based on the nature of the costs which are incurred, they both are also variable costs. But then throughput analysis assumes that labor cost and variable overhead cost are not variable in nature, but they are to be considered as operating costs, or rather they are to be considered as fixed costs. So here, sales minus, normally now, for the contribution, we see sales minus variable cost is contribution. But throughput modifies this particular thing. That is sales or the selling price minus just the material cost. Material cost, when it is deducted, this is considered as contribution. So we have this term as throughput contribution rather than contribution. So this will be called as throughput. That's the only difference what we see here. So this is throughput contribution. So the only totally variable costs are purchase of cost of raw materials or components. Direct labor costs are not wholly variable. Then, in case of multi-product decisions, rank products by looking at throughput per hour of bottleneck resource. Throughput is equal to revenue minus raw material cost. All other costs are treated as fixed costs. The same way, identify the bottleneck resource, calculate throughput per unit. There we have calculated contribution per unit. Now here we should calculate throughput per unit of the bottleneck resource. Then divide this by the usage of the bottleneck resources, rank the products, allocate the resources in order. Now, apart from that, here under this, we see there is one more formula which is given, which is called as what is throughput accounting ratio. Throughput accounting ratio is equal to throughput per hour of bottleneck resource, okay, divided by expenses per bottleneck resource. So, um, we have the revenue, that is controllable profit or throughput per unit of the bottleneck resource divided by expense per bottleneck resource. When that is compared, what is the revenue, what is the benefit which is derived, what is the expense which is incurred. So that when it is presented, we call that to be as throughput accounting ratio. Throughput accounting ratio is equal to throughput per hour of bottleneck resource by operating expenses per hour of bottleneck resource. So that is um, throughput accounting ratio which has to be calculated. How to improve throughput accounting ratio? See, if the resultant ratio has to be increased, there are two ways. One way is if this ratio has to be improved. If this has to be increased, there are two alternatives. First alternative is either you increase the numerator or you go about decreasing the denominator. In either cases, we see that the throughput accounting ratio can be improved. So that is the concept. So how to improve throughput accounting ratio? It says increase the sales price to increase the throughput per unit, reduce operating expenses to reduce the cost per hour, improve productivity, produce more number of units so that they can be sold. And then in that case, we see the numerator increasing, reducing the time required to make each unit of the product. So that's how throughput accounting ratio can be improved. Okay, so now we are under planning with limiting factors. If there is only one limiting factor, there is only one resource which is limiting in nature or short supply, then we apply key factor analysis. But what if there are more than one limiting resource? Then in such situations, we go with linear programming. So linear programming, it says this is a mathematical model which is applied with the help of the mathematical model linear programming. When two or more constraints are present, this can be solved in terms of arriving at the optimum solution, the objective. The objective could be uh, either to, if suppose the objective, if we are looking at revenue, profit, what should be done? These things should be maximized. Let's say if you are talking about incurring the cost or taking up, I mean, spending some amount on that or using time, these things, what should be done? They have to be minimized. Cost cannot be maximized. Cost has to be minimized. So that is the focus. So here, what we need to do, what are the steps in case of linear programming is, first all the variables which are present. So if, let's say if we are talking about usage of material, usage of labor, usage of machinery, usage of or the demand which is available, okay, various types of material, some of them are limited in nature. So like that, what are the variables which are used in this particular situation has to be first analyzed. Okay, first define all of them, define the variables. That's step number one. After the variables are defined, step number two is define the objective. What is the objective? Is the objective for maximization or the objective is for minimization? Then after the objective is defined about maximization or minimization, list out what are the constraints. How many constraints are present? That has to be listed out. Okay. List out all the constraints. After that, plot them on the graph. There are two ways to answer this particular thing. Linear programming can be answered either by a mathematical model. We call that as simplex method, but the syllabus doesn't cover the full length situation about simplex model. So mostly we have to go with the um, graphical model. So plot these constraints on the graph. How do we do that? We will look into that in a short while. We'll see that how to plot them on the graph. So plot them on the graph. After that, draw graph showing constraints and identify the feasible region. So after we plot these constraints on the graph the area which is covered by all the constraints has to be shaded. So the shaded portion becomes the feasible region. Then identify the optimal point and find out what is the optimal solution that has to be calculated. So these are the steps in case of linear programming. We will be looking into the questions about how do we answer such a situation. So the graphical solution looks like this. Suppose there are constraints. Constraints are plotted by lines. We see that there is one line A. A is one constraint. B is another constraint. This line is C. Okay, the line which is parallel to y-axis is C. Then we see another constraint which is this one D. So there are four different constraints which are plotted. After we plot that, then we use I mean, shading the portion like the area which is covered by. So depending on whether it is less than, greater than, then we start covering the portion, shading the portion. So the one which is highlighted by the shaded portion covered by all the lines is the feasible region. Let's say that if um, this is the region of D. So we start covering it like this, shading the like this. So it also falls into this particular then. Then if C has something like this is line C. So in that case, we see that that area is also covered in this particular place. Then we have B. B we will put it as like this only, parallel to that B constraint. So we see that lines are falling into this region. Then what did we see? A, C, B, B is done. A we will not do. A is here. So maybe we'll have this region like this. So it starts from here, curved lines. It goes like that. So we see that there is one small portion which is covered by the shaded portion of all of them, which is the feasible solution. So this area is the feasible solution that is presented here, the way the feasible. I'll just so we see that this portion, whatever is there, is the feasible region. The area which is covered by the shaded portion of all the constraint is the feasible region. So you can look at that once. So if we cover them, if we shade all these areas, depending on whatever is the constraint, the region which has the shaded portion of uh, all the constraints will be called as the feasible region. Do you see that? So there is a feasible region. So feasible region is the intersection of two lines. Do you see that? This is one point where there's an intersection. Here, this is one point of intersection. This is one point of intersection. So there is one x value, there is one y value. Okay, the region which is covered by this point, this point, this point, that is called the feasible region. So there are 5 points. 1, 2, 3, 4, 4, 5. 5 points are there. All of these points have to be substituted in the objective function. First step is when we are defining the variables, the very next thing is the objective function has to be defined. Like the objective function would be something like, let's say there are two products which are produced. So profit has to be maximized. Let's say that contribution has to be maximized. So we define C is equal to the first constraint, the let's say if this is the equation of objective function. So we have to understand how many units of A, how many units of B when they are produced. That gives the maximum contribution. Someday, if objective function is defined, these points about x and y, when they are substituted in the objective function, whichever um, data points, 5 sets are there, no? Whichever set which gives the maximum contribution becomes the solution, the optimal solution. Okay. Quickly, let's look into that. This is the graphical part of it. We will look into one question from the exam kit, so it becomes easier. What are the assumptions of linear programming? A single quantifiable object, only one object would be there. Each product always uses the same quantity of the scarce resource per unit. Then the contribution per unit is constant. Products are independent. That is, A will be sold only when B is sold, or B will be sold only when A is sold. Such situations do not exist. Each of them is sold independently. It's not dependent on the sale of the other product. Then the scenario is short term. I will come back to what is slack and what is shadow pricing little later. Um, First, we will see in the exam kit if the so from here onwards we have the linear programming questions. Question number 100. Let's take this question to the Excel file. An organization has the following contribution function. Contribution is equal to 5x plus 10y, where x is equal to the number of units of product x produced and the y is the number of units of product y produced. A graph has identified the optimal production plan exists at the point where the following two constraints cross. There are two constraints which are mentioned. The first one is about the skilled labor. The second one is about the unskilled labor. There is a maximum demand of 12,000 units of each product. What is the number of units of product Y produced in order to maximize contribution to the nearest whole unit? So we see contribution is equal to 5x plus 10y. Fine. And two constraints are given. So constraints are given, skilled labor. The equation is given. Let's try to understand what this equation means. Two products are there, X and Y. X uses skilled labor. The total availability is 62,000. Skilled labor total number of hours available are 62,000. So the requirement of hours by X and Y, each unit of X requires 6 hours, each unit of Y requires 4 hours. So that's how the equation is framed. So when the hours are consumed by X and Y, they cannot exceed beyond 62,000. They can be as much as 62,000 or less than 62,000 because availability is only to the extent of 62,000, not beyond that. So they can either use 62,000 or less than 62,000, but not beyond 62,000. So that is the indication. That's the meaning. The constraint which when it is framed in an equation, it is suggesting that there is a constraint because the availability is 62,000. So usage should be maximum to the extent of 62,000, but not beyond that. Similarly, unskilled labor also availability is 50,000. So either they can use up to 50,000 or less than 50,000. Unskilled labor, X requires 2 hours, Y requires 5 hours. Okay. In such situation, how do we answer this one? This is question number 100. Question number 100. Um, Constraints are given. We have two constraints. Constraint number one, first one, it's given as 6x plus 4y is less than or equal to 62,000. There are two options. Either it is less or equal to. So first let's equate them. Equate and make it as is equal to 62,000. Similarly, we have the second constraint which is equal to 2x plus 5y is equal to 50,000. Do you see that? So we have first equated them. These are two simultaneous equations. I hope you remember in your schooling you have solved simultaneous equations. So how to solve that? I'm assuming you know it, you remember how to do that. But even if you do not remember, what we can do is we can eliminate one unknown variable and substitute that in another unknown variable. Or what we can do is one variable can be made equal in both the equations. If we are talking about, if this is equation number one, and here if we see that, if this is equation number two, in both of these equations, one variable should become equal. So this, if this is 6x, the first equation as it is, let's take it as, we will multiply the second equation into 3. Into 3. If we do that, what happens? 2x will become 6x. So both the equations, x will have the same coefficient. So if we are multiplying the second equation with 3 by 3, so this becomes 6x plus 3 5s are 15. 15y is equal to 3 5s are 15, 150,000. So this is basically equation number 2. I hope you know how to answer this one. So when we change the sign of x, x and 6x and 6x gets cancelled. Are you not seeing the Excel? Oh, you're there on the Excel only, no? Was it sent now or sometime back? Ah, okay, okay, okay. I think sometime back message has popped up just now. Okay. Sorry, sorry. I didn't check the messages. Some time back messages popped up. Um, done. 6x and 6x gets cancelled because when we are subtracting one from another, the signs of the second equation have to be changed. Okay, so 6x, 6x gets cancelled. We have minus 15 plus 4. Minus 15 and plus 4 will be minus 9y. So we see this is minus 9y is equal to minus 150 and 62 gives us 51, 12, 88,000. Am I correct? It is minus 88,000. So we have y is equal to 88. Both the sides minus is there, it gets cancelled. And then we have minus 88,000 by minus 9 becomes plus. This is not 9, this is 11. Nobody is telling me also. This is 11. Sorry, sorry. This is 11. 15 minus 4 is 11, no? So that's 8,000. Y is equal to 8,000. You 8,000 units. So y can be substituted in any equation. Substitute in equation 1. Substitute y in equation 1. So we have 6 into 6 into no 6x. X we still do not know. 6x plus 4 into 8,000 is equal to 62,000. 4 8 is 32. So we have x is equal to 62,000 minus 32,000. 6 goes to the other side, it becomes divided by 6. So that is equal to 5,000. 30,000 divided by 6 is equal to 5,000 units. We are only asked to find out what is the number of units of product Y produced in order to maximize contribution to the nearest whole unit, which is equal to 8,000 units. So do you see that? Y should be 8,000 units. The production of product Y should be 8,000 units. Then I am pasting here the next question, which is question number 101. The question says that which of the following is or are slack resources? Let's understand what is the meaning of slack, what is the meaning of shadow pricing. So, linear program is applied when the resources are the constraint. When resources are not abundantly available, there is a constraint, there is a shortage, there is a limitation. If that is the case, utilizing these constraints, how can the profit be maximized? But slack is a situation where slack is the amount by which a resource is underutilized. Let's say 500 hours are available. There are two products which are produced. So the output produced by A is given, B is given. So A, the usage of product A for the number of hours of usage by B added together. If it is less than 500, see, they can maximize only by using 500 units. So if they do not require even 500, if their consumption of the hours or the constraint is less than the total availability, it is underutilization. Underutilization is slack. Let's say they require only 400. See, they have to maximize their profit by using all the available resources. As it is in the first place, it is not abundantly available. Some number of hours or units of the resources mentioned. So they have to utilize all of them. So that's the concept. But they are not even using all of them. The requirement of the resources by all the products is less than the availability. That is a situation of underutilization. If it is underutilized, that situation is called a slack. Okay, slack is the amount by which a resource is underutilized. It will occur when the optimum point does not fall on the given resource line. Then next, the next concept is what is shadow price. Shadow pricing, shadow or dual prices. The extra contribution that results from having one extra unit of a scarce resource. Here it is not underutilization. The requirement is there. The usage also will be till the optimum point. So if that is the case, every additional unit which is by using one extra unit of scarce resource, every additional unit of the scarce resource which is utilized, whatever is the extra contribution that is um, generated, that is shadow price. So shadow price is the concept where when one additional unit of the constraint, when it is used, how much extra contribution is generated is defined as shadow pricing. Okay, the extra contribution that results from having one extra unit of a scarce resource. The maximum premium that is over the normal cost that the firm should be willing to pay for that extra unit of each constraint. Non-critical constraints will have zero shadow pricing. The non-critical, they are not, they are available. There is nothing about they being a constraint. So these are the two concepts. While looking into the questions, we'll try to understand what is the meaning of slack, what is the meaning of shadow price. Question number 101. A jewelry company makes rings R and necklaces N. Okay. Jewelry company makes rings R and necklaces. The resources available to the company have been analyzed and two constraints have been identified. One is labor time, another one is machine time. The availability is to the extent of 2,400 hours of labor time, 410 hours of machine time. The management accountant has used linear programming to determine that R is equal to 500 and N is equal to 400. Which of the following is or are slack resources? What is slack resources? Underutilization. So, underutilization of resources is called as slack. So, whether there is any slack present or not is what we have to first understand. Question number 101. Labor time is given as 3N, 3R plus 2N is less than or equal to 2,400 hours. So, um, the first labor time, let's just substitute what is R, what is N. R and N are given as 500 and 400. Just substitute that. So we see 3 into 500 plus 2 into 400 is equal to, it should be maximum 2,400. But how much is that? 5 3 is a 15, 2 4 is a 8. 15 and 8 is 2,300. Is it 2,300? Then we have machine time. Now substitute that in the equation. 0.5 into R is 500. Substitute that plus. Then we see 0.4 into 400 is equal to 250 here and 160. Tell me how much is that? 410, exactly 410, no? This is exactly 400. So they are utilizing all the resources. 400 hours are available, and by producing R as 500 and N as 400, they will utilize all the available resources. But availability is 2400, but labor time will be underutilized. So which resource is a slack resource? Is labor time is slack resource. Did you get the concept? The next question is about shadow pricing. QPLC makes two products, Q1 and Q2, from the same raw material. The selling price and the cost details of these products are as shown below. We have Q1 and then Q2. Selling price is given, direct material, direct labor, and variable overheads are given. Contribution per unit. The maximum demand for these products is 500 units per week for Q1 and an unlimited number of units per week for Q2. What is the shadow price of these materials if materials were limited to 2000 kgs per week? So which one has a shadow price? Two products are there, Q1, Q2. Q1, there is a limitation. That is, the demand of Q1 is only up till 500 units. So 500 units only can be produced of Q1 and sold, because demand is only up to 500 units. So there is a limitation there. The contribution which is earned is 12. No, sorry. Contribution per unit is 8. Okay. They can maximize their profit only by 500 units into 8. That's it. That's the total maximum contribution which can be produced out of Q1. But whereas Q2 has an unlimited number of units per week, the demand is unlimited. So every additional unit of the constraint which is used, the additional contribution which is generated, every single unit of the constraint used, the contribution that is generated. So that is what we are looking at. So how much is the contribution generated? For Q2, we see that shadow price existing for, we see that it is possible for Q2 because Q2 only is able to, but otherwise also let's present this one. The question. number is 102. There are two products, Q1, Q2. We have selling price. Selling price is given as 20. Then we have 18. Then we have less. There are three items. The total variable cost, we can write it as directly total variable cost because it's already given to us. Total variable cost per unit, 12 and then 9.5. So we have contribution as 8 and 8.5. So this is the data which is available to us. Then the maximum demand for these products is given as 500 and unlimited number of units. But what is the constraint? The constraint is what is the shadow price of these materials if materials were limited to 2000 kgs per week. So the constraint here is material. Material is the constraint. What is the usage of this constraint? Material used for every single unit, because all these are per unit basis. Material used per unit of the product. How do we know? So availability is 2000 kgs. How do we know how much material is required? See, here we see direct material cost is given as 6 and 5. How did we arrive at that 6 and 5? By calculating the material cost as 2 per kg. At the rate of 2 per kg, when the cost is calculated, it comes out to be 6. So how many units of material was used? The units of material used was 6 divided by 2. So they required 3 units. But here in case of Q2, we see that it is 5 divided by 2, 2.5. So contribution per unit of material per kg, let's rather put it as per kg of material. Which is equal to contribution divided by the usage of material. So now in this case, do we see for Q1 it is 2.7, Q2 it is 3.4. The total demand present for Q1 is 500 units. 500 into 3 kgs is taken, 5 3s are 1500. Requirement of material for Q1 it will be total 500 units produced into 3 kgs. It is only 1500. So this is what? This is slack. The situation is called as slack because it's underutilization. Availability is 2000 kgs, but requirement is only 1500. So underutilization is called as slack. We know that. But do we see a slack situation present there in case of Q2? No, it is not slack, but it is shadow pricing. Why? Because demand is unlimited. Unlimited demand. If it is unlimited demand, then that is called as shadow pricing. So what's the shadow price? For every additional unit of resource which is used, how much additional contribution is generated is the we see that is the shadow price, which is 3.4. So what's the answer? The answer is $3.4 per kg. Did you understand? Any doubts in the solution? Let's move to the next one. The question on the screen 104. The following details relate to three services provided by RST company, R, S, and T. We see fee charged to customers. Then unit service costs are material, labor, variable overhead, fixed overhead. All three services use the same type of direct labor, which is paid at the rate of $25 per hour. The fixed overheads and general fixed overheads that have been absorbed on the basis of machine hours. What are the most and the least profitable uses of direct labor as a scarce resource? Quickly, because the concept we understood, let's quickly do this one. 104. We have products R, S, and T. So the sales price is here fee charge. That's the source of revenue. So this is 100. Then we have it as 150. Then we have it as 160. From this list, um, unit service cost. Under unit service cost, first we have direct material, then direct labor, then we have variable overhead. 15, then we have 20, then we have 15. Here we have just 30, 35, 20. Then that will be contribution per unit. This is contribution per unit. After contribution per unit, we see all three services use the same type of direct labor, which is a scarce resource. So direct labor cost is at the rate of 25 per hour. So how many hours of labor? See, the labor cost, we see that it is 20 divided by the cost is 25. So how many hours were required? We see that so contribution per labor hour. Now rank the products. Contribution per labor hour, we got it. This one is first, most profitable, least is this one, S. So then option D is the right answer. Is it clear? Did you understand? Okay. So next in the order, we see question number 109. There is a graph here. So we will take up the rest of the time. We will take up answering graph related questions. So you need to pay little attention. There are two graphs which are given to us in the examination kit. Let's try to answer. First, look at this one. Once I get this image there, it may not be very clear to us. So I hope you are able to see this one. Question number 109. An organization has graphed the following linear programming models. There is a graph given. On x-axis, we have product A, and on y-axis, we have product A, product B. There are three constraints. We see that this is first line, then second line, third line. All constraints have less than or equal to constraints. Fine. So the shaded portion will less than or equal. That is the point here. If it is less than or equal, then what do we see? All of them would move towards the origin, less than or equal to. All of them are less than or equal to. So it will fall below. It will not go above the constraint line. So when it falls below, the feasible region, if let's put it as, let's cover this one. If this is the region, the area which is covered by all of them will become the feasible region. So the lines are quite clear and obvious. So that we also we can understand. But yet, let's shade the portion. Then the second one, this line. So we'll put this one as like this, curved lines. Then the third line we see. So So if we see that this is the portion, the feasible region is this one. The feasible region would look this part of it is the feasible region because we have the portion covered by all of them. So this is the feasible region. Do you see that? The last triangle is the feasible region. The last triangle is the feasible region, right? What is the what is the maximum number of units of product B which can be produced? So on the y-axis B is the y-axis. So B is starting from 0 till this point it is 60, and A 0 to 60. Both of them are 60 60. This is the triangle which has all the uh, um, shaded portion covered by all the constraints. So all the constraints are included in the last triangle. I have highlighted that region. So we see that this is the portion which is the feasible region. In this feasible region, we have 3 points. One is 0, 60, 0, 0, another 60, 0. These are the 3 points what we see. The question is straightforward. It's asking us what is the maximum number of units of product B. B is placed on y-axis. So if B is the one which we have to look into, B has 60. Do you see that? This point has 60. Is that clear? So how many units of maximum number of units of product B should be produced is, we see that that is the number is 60 units. If this is clear, I will take you to the next one. All of you? Okay. Question number 110. An organization has created the following linear programming solution to represent the position it faces currently in the presence of short-term scarce resources. We have x-axis is represented by R and y-axis is represented by T. After that, the many constraints which are given. So I'm just highlighting, I'll zoom it. The point marked B has been determined to be the point which provides the optimal production plan. Which of the following resources will have a shadow price greater than 0? Shadow price, which constraint will have a shadow price? That's the question. So you have seen this question. So which of the following? Dark labor arts, material A, material B, machine arts. Which of them will have a shadow price greater than 0? So I'll just highlight this one. So bring it closer to you for a better uh, look at the graph. So On the x-axis we see R, y-axis we see T. The constraints are, we have material B, then we have material A, then we have direct labor hours, other one is machine hours. These are the constraints. Fine, the lines are there, the shaded portion is there. Then we see that the region is also covered. The feasible region is represented by A, B, C, D. So this is the portion, the feasible region. The feasible region, whatever are the points of x and y, when they are substituted in the objective function, one will prove to be the correct one, which is the optimal solution. So that is also calculated. They have already calculated what is the optimal point. So the mention is there in the question. It says that the point marked B, this one, B is determined to be the point which provides the optimal production plan. So the solution is also calculated. That is also done. Optimal production plan is also. So now the question, according to the question, which one of them will have a shadow price? Shadow price. Which one of them will have a shadow price? The definition of shadow price. Let's quickly go to the PPT once and then come back. So the concept of shadow price says the maximum premium that the firm should be willing to pay for one extra unit of each constraint. Okay. See, where did I? We'll go back. B is the point. B is the point which is the optimal point. That is all fine. The slide doesn't cover, but whichever constraint falls on the optimal point, that constraint will have a shadow price greater than 0. So that is the answer which you have to remember. The slide has not included that explanation, but the point is, see, we see all of them are constraints except for one constraint. Only one constraint, direct labor, touches the optimal point. All the others are above the optimal point. So the optimal point is including a region below these constraints. So let's say if at all if we shade them, so we see the shaded portion of all of them. This one, this one, this one, and direct labor hours. So only direct labor shaded portion covers this B. Okay, that falls on that. The rest of them all are above that. So even if the shaded portion is there, so all of them are below that. So we see that the total utilization will take place only for direct labor hours. All of them are above. More resources are available. More resources are available, greater resources are available than what is used at B. B is the point at which the usage is the optimal, and this is the point where they can achieve their objective function. The rest of them are not touching the optimal point at all. Only one resource which is touching the optimal point, which is direct labor. So which one of them will have a shadow price greater than 0 is direct labor hours. The rest of them are more are available. Requirement is at B. So they all of them are slack, not shadow price. So the answer for this particular question will be, the answer for this particular question, which resource will have a shadow price greater than 0 it will be for direct labor hours. A, one second. Sorry. All the other resources are above the optimal point. So the requirement is only until B. There is others are above that. So B is the point at which the availability of direct labor hours is exactly equal. It is falling on uh, the the constraint of direct labor touches the optimal point. So only direct labor hours will have a shadow price greater than zero. The rest of them availability is this much, which is above this. Utilization is only this one. So the rest of them are all slack. I hope it is clear. Maybe to better understand, we can look at, see, this is one example. What we see, question number 101. There are two constraints. One is 2,400, one is 4,410. Machine time, machine time is exactly 410. Labor time availability is 2,400. Requirement is only 2,300. So more than what is required is available. So there is no concept of shadow pricing. So underutilized ones are slack. Exactly or more than that is shadow price. So then we have defined underutilized ones are slack. So also in this particular graph, we see that the availability is there. The availability is there for these resources, which is above the usage. So this point is the usage point. Every other thing is above that. So all of them are slack. Only B is a shadow price. Please respond if this is clear. Then we can go to the next topic. Please mention if it is clear. Then we can go to the next one. Did you understand that graph? The last one, what we have done. Others also please respond. Okay. The next concept is pricing. Pricing decisions. How are products priced? What are the decisions related to pricing? So that is the next topic what we have. So Under pricing, what are the factors to be considered, the calculations to be taken up, and the pricing approaches. What are the factors to be considered when the products are priced? The first one is we see cost, competitors, corporate objectives, and customers. We're going to discuss about the factors that are to be used when pricing the product. What is the actual cost which is incurred? See, we know the selling price is basically based on selling price is equal to the cost price plus the profit. So how much is the cost is a criteria which has to be taken into consideration. What is the amount of cost? The selling price which is decided should at least be able to recover the cost. So cost becomes the primary thing which has to be considered. The criteria which is taken into consideration is cost price. Cost has to be, they have to absorb, they have to recover this cost from from the selling price which is decided. So the factors that are to be considered when the products are priced is cost, first thing. Second, it is not always that they work in isolation. They can think about what is their cost, what should they be charging. They work in a competitive market. Okay, so what is the price offered by the competitors is also very important. They cannot decide all by themselves and then say that this is what is feasible for us, this is how what works out for us. So we will only decide this price is not a situation which can prevail or exist in the um, competitive market. So they also have to consider what is the price offered by the competitor. So if the competitor is going ahead giving a discount, they also should go ahead and give a discount. Okay, so that aspect also has to be considered. So whatever the competitor strategies so competitors' objectives or competitors' strategies, those things also have to be taken into consideration. What are their corporate objectives? Corporate objectives is are they focused to maximize their profits in the short run? They want to maximize their profits or survive in the market for a long run and stabilize there and then make profit. So that part has to be looked into. The corporate objectives are see in case of certain products, we see that initially they are um, charged at very high prices. Then later on they reduce the prices. The reason for that is, see, they want to their objective is to recover all their costs very quickly. So they decide on recovering the cost at a faster pace. So they decide the selling price as very high selling price. Once all their cost, the fixed cost is absorbed, then they drastically bring down their price and sell the products. Or if they see that it is very difficult to survive in the market for a very long run, so they sell it at a higher price, maximize their profit as much as possible. Or let's say their objective is not to maximize their profit but to be there present in the market for a long run, maximize on their market share, attract many customers. So if they want to have a greater market share, attract many customers, all strategies to attract the customers have to be adopted, like giving a discount or credit period is extended, bulk purchases, some discount is there, some they repeated customers or referral customers or something like that. Many strategies have to be adopted. So that objective can be fulfilled. So whatever is the objective, according to that, the price will be decided. Then the customer's expectations, according to the customer's expectations also, prices are decided. Sometimes the customers want the products to be at a lesser price, at a discounted price. So we see that the discounted prices are offered to that. Sometimes some elite customers, they perceive the products to be of superior quality only when the price is high. So catering to them, the prices are charged very high. So the expectations of the customers, how do they perceive about the product? Those things are also taken into consideration, and the prices are decided. Okay. So we see factors to consider when pricing the products. Um, Cost is one thing, competitor, corporate objectives, and customers. These are the factors which are taken into consideration. The calculation aspects. The next topic what we have is, what is price elasticity of demand? Price elasticity of demand is equal to, see, um, in a competitive market where there are many sellers present, wide range of products available, suppliers or sellers supplying products with different features and all. So in such situation, if the seller increases the price, customers move to the competitors' products. Sometimes when the price is increased also, the customers will continue. There is no issue there. There will be no impact on the demand. So if the measurement of what impact the increase in price or the change in price has on the demand, to measure that, we calculate what is price elasticity of demand. Price elasticity of demand is calculated as, for a percentage change in price, how much is the percentage change in demand? So the relationship between price and demand is mathematically presented with an equation called as, what is price elasticity of demand. For a percentage change in price, how much is the percentage change in demand? If the calculated value is greater than 1, if the numerator is more than the denominator, then only we will have the value greater than 1. If the percentage change in demand is higher than the percentage change in price, then it is called to be as elastic. Revenue increases if the price is cut. So the price change is less than the percentage change in the demand, then we see that revenue increases if the price is cut. Price is reducing. If price elasticity is less than 1, that is called as inelastic, which means that the numerator is increasing less than the increase in, the numerator is falling less than or changing less than the change in the price. So how do we figure it out? So when the price reduces, the numerator we have the demand, the denominator we have the price. They are inversely related. Okay, if the price reduces, the demand increases. When the demand increases, more number of units would be sold. The number of units which are sold increases into the selling price. See, the number of units will increase into the price per unit. Of course, the price per unit is reducing. This is reducing. This is reducing, but the number of units, the overall demand is increasing. So the number of units increase. The increased portion of units into the revenue, the selling price per unit multiplied, the overall numerator is greater than the denominator. But now this is converted into percentages. So the formula is calculated as price elasticity of demand is calculated in terms of percentage changes. So whatever is the percentage change in price will result in a greater percentage change in the demand. Then only we have the value calculated as greater than 1. So price elasticity of demand is greater than 1 is a situation which is called as elastic. Otherwise, it is inelastic when the denominator is greater than the numerator. Inelastic when revenue increases if the price is raised. So, if there is a rise in price, okay, then the proportion change or percentage change of price increase does not result in equally proportionate change in the demand. So that part of it is called as inelastic. So we calculate the price elasticity of demand, which is equal to percentage change in demand by percentage change in price. When is it called elastic? Is when we see that the calculated value is greater than 1, when the numerator is above the change in the numerator is more than the change in the denominator. Otherwise, it's called as inelastic. The calculation aspects of it. One small point, let me highlight. Whoever scribbles on the screen, name is also visible. So that's the feature what we have. So go ahead and play with the screen. What are the calculation other aspects of it? Equation of a straight line demand curve is represented as P is equal to A minus BQ. A is the price at which demand would fall to 0. B is a gradient, change in price by change in demand. So we calculate first B and then proceed further. The total cost is also given by an equation. Total cost is equal to fixed cost plus variable cost. So we see fixed cost, variable cost is the second portion changes along with the changes in the quantity. V into Q. Q is the quantity. So that we see equation of a cost curve. C is equal to fixed cost plus variable cost. There is a portion of fixed cost which remains same, but variable cost keeps varying proportionately with the changes in the quantity. Then when the cost rises proportionately, we see that when the quantity increases, then there is a discount which is given. For bulk order purchases, discounts are given. Fine. That is all what we learned till here. Pricing approaches will start in the next class because it takes some time to go through all of these pricing approaches. So we'll take it up in tomorrow's class because quite a lot are there. After that, maybe we will also finish relevant costing in tomorrow's class. Any doubts? Anyone who's absent? Okay then. Avinash. Do you have a holiday in college today? Or is it a working day today? Okay then. See you tomorrow. Good day. Enjoy the rest of your holiday. Good day.
Thank you.